Listen, I just want to welcome everybody to the 932nd monthly meeting of the Amateur Telescope Makers of Boston. The July meeting is typically a member night, and we have 4 speakers slated to talk tonight. And so here we go. So Glenn was nice enough to send me some slides for the observing report, and so this, of course, is his comic of the month, which shows, does this mean they're done with the cows? I think those are penguins being abducted by aliens. And Glenn's quote for the month: there are 2 creatures who like to stick their heads out of the windows of moving cars, dogs and amateur astronomers. And that's a quote by the famous amateur astronomer Dale Church. And I'm going to leave it up to you guys, you folks, to look that one up online yourself. Very famous astronomer. You all know and love him. In the morning skies, we have Comet Neowise. If you've been looking at the pictures online, they're pretty impressive. And they show a comet with a nice dust tail. And if you look closely, a very faint gas tail. The comet is very low in our skies, right at first light in the morning, which is making it a little bit difficult to get people out of bed. And you need a really good view to the northeast to see it. So it will become visible in the evening sky soon enough, and that's what I'm sort of waiting for. And so that's good. Do you remember Hale-Bopp did the same thing? Hale-Bopp was visible in the morning sky for the longest time, and then it finally became visible in the evening sky, which took the edge off of everybody losing sleep over it. So that was pretty good. There's another comet in the sky, Comet Lemon, much fainter and a bit more difficult to look at, but you can see its path through Leo and into Virgo over the month of July. Let's try this one. Upcoming sky events for July of 2020. On Friday morning, tomorrow morning, Venus reaches greatest brilliancy at magnitude -4.7. That's pretty bright, and that is absolutely bright enough to see it in the daytime sky. If you can locate it against the blue background, you should have no trouble seeing it. Venus reaches greatest brilliancy 36 days before inferior conjunction, and again 36 days after inferior conjunction. It's a fat crescent, and I think you should all get out there and take a look at it. On the 14th, Tuesday, Jupiter is at opposition closest to the Earth around the date of opposition. On Friday, July 17th, Venus and the waning crescent moon will be together in the sky. On the 20th, Saturn will be opposition. The rings are tilted 22 degrees to our line of sight. And Mercury is at greatest western elongation. That means it's in the morning sky on July 27th. There was so much to show over the coming months that I split it up into 2 slides for Glenn. On Saturday, August 1st, in the evening sky, the waxing gibbous crescent moon will be near Jupiter and Saturn, put on a nice show. Of course, the annual Perseid meteor shower peaks somewhere around the 11th and 12th. I don't think the moon's going to be much of an issue. I don't think so, but I'll have to check that. On Wednesday, August 12th, Venus is at greatest western elongation, 46 degrees away from the sun. A special event for August is at Jupiter on the 15th. It's in the wee hours of Saturday morning, 12:08 to 1:54 a.m., a double shadow transit of Io and Ganymede. Ganymede's a very large satellite, and it casts a really big shadow. So that should be relatively easy to see in backyard telescopes. Probably bigger than 3 inches, but scopes that are 3 inches and above, you shouldn't have any trouble seeing that. It's pretty good. In the morning sky, that same morning, Venus pairs with the waning crescent moon. The lunar X is visible on August 25th, around 9 o'clock in the evening. That is a clair obscure play of shadow and light that occurs once a month, and in August we'll be lucky enough to have front row seats for it. So that'll be pretty good. And then finally on the 28th and 29th, the waxing gibbous moon is with Jupiter and Saturn again. So that should be a pretty good month, a month and a half, 2 months of observing. That should be kind of fun. The Observer's Challenge for July is Messier number 8. That is the Lagoon Nebula, located in Sagittarius. It's a nice, easy object to find. Fairly bright emission nebula, responds really well to ultra high contrast filters. And so if you are out looking at it, jot down your notes and send them to Roger Ivester and Sue French and become part of the Observers Challenge. This is a nice, easy object, especially coming off of NGC 5689, that faint little galaxy that was last month's object in Boötis the Herdsman. Very, very difficult galaxy to look at. But M8 should prove to be a bit easier. You probably already all saw it, have already all seen it. And there are some lovely photos. If Glenn were on, he would tell us who took those pictures. I know our regular contributors are Mario, Motta, and Doug Paul. So if you guys did those, nicely done, very nicely done. For August, a skip and a hop away is Messier number 20, the Trifid Nebula. Also responds well to ultra high contrast filters, but still pretty easy to find. And again, if you're even a casual observer, you've probably looked at these objects in the past. There's a nice shot of it, and I think, Glenn, is this your sketch? Not if it's yes, yes. Glenn's saying yes, that is his sketch. So really what's key here are dark skies. Both of these nebulosities, if you don't have a really dark sky, try to employ ultra high contrast filters for these guys. They should respond nicely to that, and they're quite pretty to look at. So again, write up your notes and send them to Roger. That'll be pretty good. Let's see what's next. Al Takeda sent me this morning, and I don't know where all these crazy little lines are on my screen. Again, I apologize. But Al was brave enough to try and photograph the penumbral lunar eclipse on the evening of July 4th and 5th, just a couple of weeks ago. And this is a GIF that shows pre-eclipse and during the eclipse to show you how slight the shading was during this eclipse of the moon. Penumbral eclipses, unless they're probably about if the moon is about 2/3 of the way through the penumbra at its deepest point, unless it's that deep or deeper, the visibility of the shading on the moon is almost non-existent. The internet hyped this eclipse up, and I wondered to myself how many people went out that evening to look for this great eclipse of the moon and really got to see nothing at all. Penumbral eclipses are largely non-events. If you were an observer on the moon during a penumbral eclipse and you look back at the Earth, you would see, or you looked at the sun, you would see a partial eclipse of the sun. And so we like to wait for nice umbral eclipses. The next one visible from here is in May of 2022. So not too bad, a couple of years away. And so we'll see what works out with that. And Al was also up very early this morning and caught a look at Comet Neowise. I don't know if Al can talk to us, but I'm sure he would tell us what it looked like. There are two supernovae in the skies that you may be interested in looking at. They're in the western skies right after sunset. The sky doesn't get dark enough these days till about 10 o'clock, but these two supernovae are fairly bright and should be visible in moderately sized backyard telescopes. In NGC 4457, there's an 11.5 magnitude supernova right adjacent to its nucleus. Now that's a fairly faint galaxy in Virgo, but that supernova is pretty bright and it's well worth a look. 2 months ago, the Observers Challenge was M85. And if Roger and Sue had waited a month or two, one of us may well have discovered supernova 2020 NLB. It's currently about 12th magnitude, and it's actually really easy to find. I don't know if you can see my cursor. This star here is relatively bright. This star here, as you can see in this picture from Sky and Telescope, the galaxy is sort of involved with that star. This star here is actually a foreground object. Here's the supernova. They're about equally bright, and so that should make seeing the supernova pretty easy to do. So I encourage everybody to go out and have a look at that, and let us know what you see. This is a really a nice view of the west right after twilight, and you can see the location of those two galaxies. M85 is in Coma Berenices, and NGC 4457 is in the bowl of Virgo, not far away from. We have speakers tonight. Mario Motta is going to talk about the galaxies of spring. Kelly Beatty is going to talk about an Aurora adventure in Iceland. James Chamberlain is going to talk about an Australian observatory tour. And if there's time, I'm going to talk about daytime observing. Now, I know it's already 8:44. I think I'm going to push mine off till September because I think we're going to run out of time. I really don't want the meeting to go much past 10 o'clock. I don't know what all your plans are, but let's try not to make this thing go all night. But I can't wait to hear Mario talk about the galaxies, and I can't wait to hear Kelly's talking about auroras, and James has got some awesome stuff about Australian observatories. So I'm going to stop sharing my screen. Mario, you're going to come online, right?
Yeah. There we go. Okay, now it's full. Seems strange not starting off with dumplings and calamari, so I'll do the best I can. Anyways, this talk was inspired because a member of the GAC club asked me a few months back why I always consider spring the best time of the year. And I said, it's because it's got galaxies. It's galaxy season. And they said, well, why is that? Aren't galaxies distributed everywhere in space evenly? And if you look deep enough, that is absolutely a true statement. But if you look within 100 million light years, that is not a true statement. And so I'll talk about why galaxies are unevenly distributed in space. And also it'll give me a chance to show off some galaxies so Rich doesn't show the moon. So anyways, Virgo cluster, the center of it has 2,000 galaxies just within about 5 degrees. Virgo supercluster, that is the region around it. We're part of the Virgo supercluster. It's 47,000 galaxies. So it's a rich area to observe. But why is it just the spring? So here is a large-scale view of what galactic distribution in space is like. If you look at a small enough area, it's not even. But if you look at the big area, it's isotropic in all dimensions, in all directions, and you have an even distribution of galaxies. But, you know, unless you own the world's biggest telescope, we don't see that deep. So if you look up close, as the galactic distribution is kind of like this. Now, these are not strings, they're more like planes. So if you are really up close to this spot here, if you can see my arrow, you'll see this giant plane of galaxies. But if you look to the right, to the left, not so much. And that's basically, but if you step back a bit, galaxies start to become more even. So here is our local area of the universe. This is where the Milky Way is, and we're on the edge of the Virgo cluster. We're part of the Virgo supercluster, which means if you look in toward Botez and Hercules, not too many galaxies. And the reason is we got this local void that's about 400 or 500 million light years of nothing. A couple of little spots, but that's about it. In the fall, you look at in this direction and you got galaxies, but it's not as rich as looking straight into Virgo. So hopefully that's fairly clear. So looking across the Hercules-Botez border, this is what it looks like. Able 2151. It's about a 4-hour image I took. And basically everything you see here is a galaxy. It's a couple of stars, okay, but not many. Just all these little dots, if you blow it up, are galaxies. And I counted at one point, there's something like 80-something galaxies in this 15 by 15 arc-minute picture, which is pretty impressive. But that's because it's 500 million light years away, and we're looking at basically a wall of galaxies in front of us across a gigantic void. So unless you got a gigantic telescope, these are not very accessible. So looking toward the center of Virgo, this is a picture with my refractor, so you get a wider field. And here's the center of Virgo, and it's just chock full of galaxies. Okay, M86, the giant ellipticals are the center of that. And these are all about 60 to 70 million light years away. And there's galaxies interacting, lots of tiny galaxies. Anything that's fuzzy here is a galaxy. And they're all kind of slowly drawing into the giant ellipticals. So this is M86, which is the very center. This is M86 through the 32-inch. And again, the giant ellipticals are gigantic galaxies. So here's the eyes, which are right here, and they're kind of interacting and slowly being drawn in to the giant ellipticals. So let's step back a bit more to our neighborhood and look over. So if you look, remember that giant plane I was talking about? If you imagine that being from basically is Ursa Major all the way down to below Virgo and Corvus, that marks a giant plane. And the galaxies that are close to us are going to be distributed from high north to deep south because they're close to us. It's like looking at a tree at the edge of a forest. If you look past that tree, you get to what looks like smaller and smaller trees in the distance. If you remember that, again, 3D distribution of galaxies. So M51 is relatively close, and that's why it's big in scopes. So here's an image, color image of M51 through the 32-inch, and it's an interacting galaxy, which are always interesting. So here's another one that's reasonably close, M81, and this is only 12 million light years away. And you, again, you can get nice detail because it's close. And this is way up north on the upper edges of Ursa Major, still on the outskirts of the Virgo cluster, but because it's close to us, we're seeing it off-centered from Virgo. This is M63, heading down along that plane. It's a flocculent galaxy. 4565, again, heading down that plane. I think consider this probably the best edge-on galaxy we can see from Earth. Well worth looking for those who haven't seen it visually. It's beautiful even in a small scope. M64, the Black Eye Galaxy. Again, nice detail because it's not that far away. I think it's only 20-something million light years away. We're slowly moving down through Canis Venatici and heading into Virgo. So in Leo, to the right of the center of Virgo, you got 3648, the Hamburger Galaxy, and the edges are puffed out, not like 4565, and that's because it's gravitationally being pulled on by 65 and 66 down below. So this is one of my favorite, 4631, the Whale. This edge looks like a normal edge on. This edge does not. Notice it's all kind of blown. It looks like something happened over here. What that something was, this galaxy here had a close interaction, may have even gone through it, and is heading in this direction. So a few more passes and this will become like our Magellanic Clouds, eventually getting ripped apart and become part of 4631. But whenever you see a galaxy that's misshapen, that's interesting. Look at it closely. You'll usually find out the reason. It's either another nearby galaxy or a small galaxy that's interacting with it or disturbed it in some fashion. I always find those interesting because it's different and unusual, unlike the dead moon. So here is, Rich, you might as well get used to this for the next 2 years. I'm sorry. 4302 and 4298, interacting galaxies. They're not quite close enough to create nice big tidal bulges, but they are interacting. Move again further down in space, 4631, and also some accessory galaxies around it. It's a nice spiral. If this was a little closer to us, it would be a nice match for M51, the Whirlpool. M109, again in the Ursa Major region. It's a very nicely detailed galaxy. You can see all these beautiful H alpha regions, these knots. Those, of course, are not stars. They're H alpha regions that have been active. And why is it active? It's probably because there's something else in the near neighborhood. There are these galaxies here are far distant, but I believe just off the field of view, there are a couple of other smaller galaxies that may be interacting with it. And that always causes gravitational ripples, which then causes nebulae to start producing stars. That's M109 is a beautiful galaxy for that reason. Of course, M104 is always a summertime favorite down in Corvus, and it's an SC galaxy with a giant core and a nice dust band going across. You can make out spiral arms, but they're very tight, and also it's tilted in the direction you can't see the spiral arms very well, but they're there. And,
Mario, some of those,
I'm sorry, what?
could you go back to 104? Are those little fuzzy dots in the halo, those are globulars, aren't they?
They are, indeed. There's something like, I don't think I caught all of them, but there's something like 100-something globulars around 104. But what Rich is talking to is all these little fuzzy spots. Okay, these are the stars. They're nice, sharp, bounded. But these fuzzy things, those are all globular clusters. Here's another one up here, another one here, another one here. Thank you for pointing that out. M83 is one of my favorites, low in the sky, and you have to have, from New England at least, you have to have a real steady night in order to get some detail out of it. But I had a good night and I was able to get some good detail of M83. Go deep enough, you always get distant galaxies. All these, anything that's fuzzy in the distance, those are all galaxies surrounding it. But M83 is a beautiful barred spiral. Here's 4038 and 4039 in Corvus, which are two interacting galaxies. Because as we head toward the center of Virgo, there are more and more galaxies interacting just because space is more crowded there. And these two galaxies that have passed through each other, and kind of like throwing a rock in a pond, you get these gravitational ripples. That's what these are. Basically sheets of stars that have been thrown out. It's kind of necessary in order to lose the angular momentum, or these would never merge. So the vast majority are going to merge because these stars got sacrificed and got thrown out. Eventually, they'll probably spiral back, and 2 billion years from now, they'll become part of the galaxy as well.
Mario, is that known as the mice?
No, that's up in, where is it? Those are in Canis Fanaticis. This is not the mice. This is known as the antenna. Similar idea though. I got to get a good picture of the mice. It's on my hit list. This is NGC 3178, also known as a polar galaxy. Again, it's two galaxies that have in the process of merging. But what I like about it is they're merging at 190 degrees perpendicular. So you got this beautiful spiral, and then you got this other spiral. See the band going across? That spiral arms got flung out, and a lot of interaction, as you can see. So it's kind of a chaotic environment, but it's called a polar galaxy because they're like this right now, as opposed to other mergers that are more flat on. And the other reason I like this photo is in the distance. This was a multi-hour exposure, and whenever I do that, you get galaxies all over the place. So these are all galaxies. These are all galaxies. These are all galaxies. There's something like 50 galaxies in this field of view if you got a nice up close look. But what's really nice is down here. Now this is about 30 million light years away. These down here are a whole slew of galaxies that are interacting, 4 of them, and then another one off on the side. And these 4 are, I tried to look it up, and the range is not completely known, but it's in the 600 to 800 million light year distance. So something reasonably close, something far away, but it's all incredibly interesting. And get the Siamese closer to the center of Virgo, which are 2 beautiful spirals collapsing. These are further, these are about 90 million light years away. So we're on the other side of the giant ellipticals. And then there's a whole bunch of smaller galaxies in the distance. 32, 26, and 27. See all this fuzz? It's not because I processed poorly. That's all real. Here's a spiral galaxy. Its spiral arms are no longer defined well. This one kind of got ripped apart. Inside of it, you can see H alpha regions because of this interaction. And all this fuzz is basically stars and dust and gas that have been interacted with and blown out because of this. And I want to do this one in color at some point. I think it would be a spectacular object. Closer to the center, 4394 and M85. So here we are into the central portions of Virgo, and the central part of Virgo is dominated by giant ellipticals. That's because it's had 12 billion years to coalesce all the spirals into these giant ellipticals. And you can tell that this is a coalesced galaxy because notice this has shells, okay? Those are real, and those are epochs of mergers of galaxies, and they still retain their individual orbits, and it forms these giant shells, which eventually will probably die out. And this fuzz out in the distance is because galaxies are still interacting. Here's a smaller galaxy, I think, fallen in. And here is 4394. Notice it's got lots of hot H alpha regions. That's because of the gravitational pull of this, causing the spiral arms to create stars. Now this is processed M87, another one of the giant ellipticals in the center of Virgo. So it's chock full of them. And this one I processed to de-emphasize the center so you can see this little spike. Everyone see that? That is a jet coming out of its black hole in the center. Okay, so you can, in really big scopes, you can see that jet and it images well, but if you process it so this is bright, you kind of lose this in the glare. Now, Rich, you want globulars? See all these dots?
I was going to point out that it's just studded with them.
This is, I processed it specifically to bring those out. There are hundreds of globulars surrounding M87, which speaks to the epochs of mergers that created it to begin with. Okay, so this is, to form something like M87, you're talking 5 or 6 ordinary spirals coming together over time. And so a couple of hundred globulars over 5 or 6 galaxies, you got 600-700 globulars surrounding it. Here are 2 galaxies merging, falling in. It's just an interesting field. But yes, those are all globular clusters way in the distance. And here's the one photo tonight I did not take. Okay, but this is the black hole at the center of M87. See that jet coming out that I got? That's coming out of this thing. And that is made history because it took 2 years of a worldwide effort, but that is the first image of a black hole. It's a spectacular image, and it just, whoops, and it just goes to show what's in the center here. It's
well, I don't have any new grandchildren. Sorry. You know, by way of background, some of you might know I'm originally from Central California, where we never, ever, ever have auroras. And I moved to Boston like 45 years ago with a hope of seeing auroras way more often, because you're supposed to have them, you know, statistically, I don't know, like 10 or 20 times a year here. But that didn't prove to be the case. I have seen a couple weak displays here. I saw a good one at Stellafane one year. I saw one up at Madomic in Maine. And so, with that as background, my deep auroral experience, I led a tour of folks to Iceland last September on a Sky Telescope tour, and this is that story. But first, I'm gonna give you a little bit of historical background about auroras. This is just a great quote The white-capped billows of light are shifted and then break on a shore of shadows dim. I just love that wording. You know, auroras are, to me, one of the most dramatic things in astronomy. Certainly they don't top a total solar eclipse, but literally the Earth is under attack. And you can imagine ancient peoples having in northern and extreme southern latitudes seeing these things, was trying to figure out what was going on. The Finnish believe that it was the tail of the Arctic fox brushing against the snow and mountains and letting sparks fly. That's very picturesque. The Sami in Scandinavia believe that this was light that you can hear, and there actually are a lot of studies which I won't go into tonight about the persistent reports that auroras can be heard. It has to do with electrostatic discharge. In Gaelic, they called them merry dancers, and the Scots imagined battles between fallen angels or sky warriors. And the Inuit thought that they were spirits playing ball games with the skull of a walrus. I like that. Now, as a background here, these are all images. This in particular is an image of auroras from Iceland, which is where we were headed. And curiously, in Norse and Icelandic mythologies, there are no real mentions of auroras, which I find very interesting in and of itself. So fast forwarding, you know, around the 1700s, enlightened minds tried to understand what auroras were, much as they were trying to understand what meteors and meteorites were. So here's one to liken them to armies engaged in the sky. And so people some of whose names you know, had back and forth about what auroras might be. I loved Halley's description, magnetical effluvia. And there was some thought that maybe they came from the sun's atmosphere, or as Dortus de Moraine thought, they were just reflections from snow. So scientific inquiry proceeded, and people started making careful sketches of them to try to understand what they were about. And it was Angstrom, a Swedish scientist in the late 19th century, who came to the conclusion that they were from excited gas, having taken their spectra. And you can see that it's basically a line emission, not anything like the sun, which is mostly continuum. And so the question is, what were those various emissions? And so later on, Birkeland and Stromer advanced aurora science. Birkeland in particular created a sort of you can see, man, that he had a lot of electrical horsepower there, and he essentially created auroras in his laboratory with plasmas and electrical charges. So what are auroras? Believe it or not, a standard fluorescent light bulb is a pretty good analogy for an aurora. And so let's see. Can you see my cursor here, the upper right?
Yeah.
So, all right. So in a standard tube, actually a fluorescent light bulb is pretty complicated. First of all, you have these anodes here that are emitting lots of electrons as they ionize. Basically, they're ionizing the mercury and argon vapor within the tube. And the presence of these electrons in the plasma allows the electrons to really race through the tube at quite high speed. In doing so, occasionally an electron will interact with a neutral mercury atom, shown here as the gray circles, and it causes the electron shell in those mercury atoms to become excited. And as is often the case, when an atom becomes excited, when that electron returns to its ground state, it emits light. And in this case, it emits ultraviolet light. And that becomes important when you study auroras of like Jupiter and Saturn, where the auroras are present, but they're in the ultraviolet. In the case of this tube, the ultraviolet light is absorbed by a phosphor coating on the inside of the tube that re-emits it as visible light. And so this is essentially an aurora in the tube. So let's talk about our tour, for example. It was with this as background that I led these intrepid Aurora wannabes. There were about 35 of us all together, and this was I think the 6th time we had taken a trip to Iceland for Aurora hunting, and we had a great group. We saw all kinds of stuff. This is something called the Blue Lagoon, which is not far from the airport outside of Reykjavik. And I want to point out there are a couple of people here that have like white faces, and this is like a pond with salts as a sediment on the bottom, and you scoop this stuff up and slather it all over your face, and it's supposed to be good for you. Who knows? Here we are at a waterfall in Iceland. For those who've never been, there are so many awesome, mind-blowing waterfalls that they start to get boring after a while. This is called Skogafoss. Foss is the Icelandic word for waterfall, and it's just an amazing sight. And the geology, my bachelor's degree is in geology, and it's just mind-blowing. This is called columnar jointed basalt. There's a lot of volcanism on Iceland, and this is a basalt that has cooled very slowly, and it develops these fracture patterns like stacked pencils. There are very few really good outcrops of this anywhere in the world. One is Giant's Causeway in Ireland. Another is near my hometown in Central California, the Devil's Postpile in the Sierras. And Iceland is known as lying atop the mid-Atlantic rift, where literally the oceanic plate is being pressured from below, and it's splitting and cleaving apart and pushing itself toward Europe and Africa on the eastern side, and toward the Americas on the western side, and it goes right through Iceland. And here I am doing my best impression of pushing the continents farther apart, with great success, I might add. So let's talk about auroras and how they actually occur. This is what we were there for. We were hoping to see lots of auroras, and typically auroras happen because there are energetic events on the sun, flares and such, that propel matter through space toward the Earth at high speed. This is a little video that I found. It's about a minute long that really explains this very well.
During solar maximum, solar storms can occur several times per day, and sometimes they are aimed in the Earth's direction. When the solar storm reaches Earth, something strange happens. It's as if it is deflected by an invisible shield, the Earth's magnetic field, the magnetosphere.
I want to stop this for just a second. I want you to notice that the field alignment of the solar wind magnetic field is opposite that of the Earth. That will become important later.
Together and create a funnel for the gas streams down on the daylight side of the pole. This is the daytime aurora, which our eyes cannot see. The magnetic fields stretch further rearwards and couple together. The magnetic field, stretched like a rubber band, break, and gas from the solar storm streams back along the magnetic lines towards the polar regions on the night side. This is nighttime aurora we can see.
So just to recap, when there are flares on the sun from the sun's active regions, that propels matter in specific directions and often toward the Earth. These are much more common at solar maximum. And this is what's called, these result in what are called coronal mass ejections. The white circle there in the middle is the sun, and it's been masked by that black circle there. And this shows one of these blasts. Now, clearly this particular blast is going off to the side. When you see one of these blasts and it's sort of radial to the sun, as seen from the spacecraft, you know that it's headed in your general direction. And the last way that auroras happen is through what are called coronal holes. These are essentially weak spots in the sun's magnetic field where the lines stretch out into space, and the solar wind, which is a plasma basically, can follow those field lines and escape the sun at high speed. This is a little animation showing a coronal hole. This is not a visible light image. This is a far, this is actually an X-ray image, soft X-ray image at 193 angstroms, taken by the Solar Dynamics Explorer. Cool stuff. Okay, so this is what we were after. We were headed to Iceland to try to find auroras. When those particles cascade down through the atmosphere, they attack the atoms and molecules in the upper atmosphere of the Earth, and we get these various colors. And so I'm going to kind of walk you through what happens. Now, it's important to understand that when you get to high altitude in the Earth, the nitrogen molecules, that is two nitrogens together, and oxygen molecules start to break down, and they're much more commonly single atoms of nitrogen and oxygen than there are molecules. So when you get to about above 120 miles, when these electrons, mostly cascading down the magnetic field lines, hit the oxygen, it causes their electrons to become excited. As the electrons into the ground state, they emit red light. Those are from oxygen atoms. A little lower down, you get the same process, exciting nitrogen atoms, which glow blue. And then, neither of these cases involve ions. These are simply excited atoms, much like that fluorescent tube. But it's possible to actually ionize the oxygen, and that's where you get that distinctive green. That's the most common. And then if the electrons are extremely energetic, they can get way down into the atmosphere, below 60 miles in altitude, and attack and activate nitrogen molecules, which will glow magenta. So the two colors that you see most often are this very distinctive yellow-green, which is the ionized oxygen, and the red, which is higher up, and that's excited oxygen atoms. There are a couple of ways that we, as amateur astronomers, can keep tabs on the auroral potential, and I think that many of you probably already do this. There's something called the KP index, which is an indication of the disturbance of Earth's magnetic field, and also B sub z, which is the direction of the orientation of the sun's magnetic field in the z direction. And when that goes negative, it has the potential to hook up and connect with Earth's magnetosphere in a way that allows that solar wind plasma to come cascading in. There's a couple of other ways. I'm showing you these mostly so that when this gets posted, you'll have these sources. There are all kinds of sources for the auroras. Here's this in this top panel here, the red is indicating the B sub z direction. And when you see it go below the dashed line here, that means it's negative, and that's good for auroras. Here's a more graphical depiction. The Space Weather Prediction Center of NOAA does a really great job with all this, and so I'm not expecting you to copy all this. Again, when you play back through this tape, you can see all of these sources for tracking the aurora. This is the kind of material that I was using, trying to understand whether we would be lucky enough to see auroras in Iceland. Well, of course, some of you might know we're here right at the solar minimum. We had very poor prospects for seeing auroras, I'll be honest with you. We did not expect much at all to be happening. The tour before us in 2018 had seen auroras only weekly on the very last night. So I was not very optimistic at all. And that was only underscored by the fact that on the day we arrived, September 26th, the sun was completely spotless. There was nothing, nada. And when you look at it in X-rays, however, there is a little structure there, and the dark areas are coronal holes. And so it turns out that one solar rotation earlier, in late August, there had been a really big coronal hole that had triggered some auroras. And as the sun spun around one rotation to late September, that coronal hole was again facing the Earth. So there was at least the possibility. And in fact, we got a word that there had been a blast of that coronal hole headed in our direction. So we had our fingers crossed that we were going to see something like this. This was where we stayed the first night. It's called the Northern Light Inn. And you know, from the way this picture is taken, you think this is the most remote, amazing, beautiful, star-filled sky ever. What they don't tell you in the brochures is that the inn, which is down here with the red roofs, is right next to a gigantic thermal power plant. A lot of Iceland's power, most of it in fact, is powered by geothermal power. They sink pipes into the ground and extract the hot water and use that to run turbines and generate all the electricity they need and more. And this thing is lit up 24/7. It was awful. And it was tough to get away from it. But as it turns out, thanks to that coronal hole, on the very first night we were here, we had a fantastic auroral display. And this is a picture I took. You can see down here at lower right, this is the glow from that power plant over there that is only barely blocked by the building. You can see that the stars are quite visible. It was a pretty dark location. Here's the Pleiades way over here. I'm facing more or less east here. And you know, I hadn't really any experience at all taking photos of auroras. And so my beginner's mistake was that I used too low an ISO value. It was around 800, and too long an exposure. These were like 5-second exposures. And during that time, a lot of the detail gets blurred out. What you don't appreciate until you see one of these by eye is that these things are dancing all the time. And there is so much structure. And these first couple of photos I'm going to show you just didn't capture it at all. But they are pretty dramatic. These were curtains that were nearly overhead. You can see the Big Dipper. Now I'm facing north. Here's the Big Dipper up here. And this is my wife, by the way, Cheryl, enjoying the view and some of the people. And I told all these people in the foreground, don't move for 5 seconds. I got that. And here's another one. So this was all the first night. And it was so fantastic. It just went on and on and on. And we were completely giddily satisfied. And if we hadn't seen any more auroras the whole trip, that first night would have made it true. Would have made it fantastic. But wait, there's more. We had auroras for 4 nights in a row. This was the second night. We're at a different hotel here. And by this point, I had figured out how to make time lapses. And I'd also reduced the exposure to about 2 seconds apiece, up the ISO and increase the ISO and shorten the exposure. And what I want you to notice is you saw that first wave. Here comes a second wave about 15 or 20 minutes later. These things come and go. Here was the third night in a row that we had auroras. Again, this is facing north. You can see the Big Dipper there. And what's really cool is you see the clouds moving in. These auroral displays are so strong that even when it's overcast in Iceland, you can see the green curtains like making the clouds glow. And then 2 nights later, we had our last good night. We went out to a dark sky location that's a sort of a fjord in the foreground there. And you can see that the auroras are dancing near the horizon. By now I'm smart. These are only 1 second exposures. You can see the curtains and the reflections in the water. I want to mention, I'm going to actually back up to this one briefly. This one right here. You'll be able to see over here on the left, there are hints of magenta above the green curtains. We didn't see any of this color at all. On that first night, we barely saw the green. That's just the way the rods and cones work. It has to be a really strong auroral display to see all the different colors. And although we had good ones, they show it way, way better in the cameras than they did by eye. It was certainly, we had, of the 6 nights we were there, we had really great auroras. 4 nights, we all went away very happy. Someday, some of you might get a chance to do some auroral photography. It's not unlike what you do for general astrophotography. These are instructions that are going to be familiar to you. I'm putting these up so that, again, when you replay this, when next time you go to Iceland, Bruce, I think you're going to Iceland, or you have already. Interesting thing here is that the white balance you want is fluorescent, not auto, for sure. Do not use auto white balance. Pick a white balance. Fluorescent gives the best result. If it's a super bright display, you can try video. It wasn't very successful for me. I want to show you, just to close, this is somebody who really knows what they're doing and was up there for a long time. Just sit back and enjoy. This again is in Iceland. Those, by the way, that last little bit there, those are called coronas when it's directly overhead, shining down on you. It is just an amazing thing. So that's it for me, Rich. I turn it back to you.
Right. Well, thanks, Kelly. That was awesome. I can't remember the last time here in New England I saw auroras quite like that. My recollection takes me way back to the late 1960s, early 1970s. There were a couple of stellar things where you couldn't do astrophotography because the sky was so lit up with aurora displays. And you're right, the movement is, it almost makes the hair on the back of your neck stand up. Even when I think back to that first aurora I saw, it was like, that is just incredible.
Yeah.
And they're fun to look at. Oh, awesome.
And I have to say, we had planned another aurora trip this coming September. The pandemic has complicated travel for everybody, and we've actually canceled that trip. And it's probably just as well because, again, we're pretty much still at solar minimum. And I recognize that we just lucked out. You know, we had that very well-positioned coronal hole. Had that not been there, we'd have probably had goose eggs for 6 nights in a row. In fact,
Sure.
My wife Cheryl and I arrived a day early, and we stayed near the airport, and we met a huge group of Chinese amateur astronomers who had been there for 2 weeks, saw nothing in 2 weeks.
You were lucky that the weather held up.
Yes, that too.
Iceland's not known for its clear skies. Did anyone hear any of the sounds? Did any aurora, were them intense enough?
No, but it turns out that one of the leading, I think he's passed now, but one of the leading researchers on auroral sounds was a guy in Lexington named Sam Silverman. I don't know if any of you ever crossed paths with him. I interviewed him a couple of times. It's rare. The sounds are rare.
Yeah, it really is. But there've been reports for a long, long time about people hearing sounds. So it has always intrigued me. Well done. Well, hopefully this next solar cycle will be better. That graph you showed doesn't look it.
No.
The
prediction for the next, which is cycle 25, is to actually have a sunspot peak that is at or less than what we had in 24. And for those of you who watched the sun a lot, you know that we weren't exactly awash with sunspots during the last solar maximum. So we're in kind of the doldrums here.
And Kelly, you know, a lot of the graphics that you showed for predicting auroral displays, I use spaceweather.com.
Yeah.
A lot of that stuff is right up on their front page. So that's a handy source of information when you're trying to figure out if there might be an aurora.
Yeah, Space Weather actually, I think they still have an auroral alert where they'll call you in the middle of the night. And these hotels that you go to, depending on the hotel, if you let them know that you will do anything at any hour of the night to watch an aurora, they will call you at like 3 in the morning. Hey, you know, get your tail outside. There's an aurora going. Yeah. But Rich, I think the Space Weather Prediction Center, swpc.noaa.gov, is the sort of one-stop shopping for that stuff.
Awesome.
For the prediction.
All right. Well, that was great. Did anyone else have questions for Kelly?
Yeah, I just wanted to say, Rich, this is Bruce. I was scheduled to go in September on a tour led by our member Babak Tafreshi, although the European Union just announced travel bans from people from the United States, and Iceland is part of that deal. So The September tour has been called off, but there's another one coming up in March, and there's a few places left.
Don has his hand up. Now, if we can just unmute you, Don. There you go.
Yeah, it was reported today by the ARRL. A group of scientists have studied quite extensively the history of solar cycles, and they are predicting a higher peak. They are predicting a better than 65% chance that we'll see from 185 to 300 sunspots on the sun at peak.
Wow.
So
That's very interesting, Don. And you know, the thing is this, if you go if you dig down into the NOAA prediction mechanism, they create what's called a consensus model. So they take people like, you know, solar scientists from around the world, and they sort of pool all of their predictions together. I hadn't heard about the ARRL. I can see by your little call letters there that you're a ham. So I'll look into that. Thank you.
Hey, Kelly, are there any more tours up and coming, or that you could share with us? Or
Yeah, so some of you know I have retired from Sky and Telescope, but I'm still engaged as a kind of contractor, specifically to do tours. And so we have 2 tours running to South America for this coming December. We're keeping our fingers crossed that will still happen. One's a cruise, the other's a ground thing. What I've been working on mostly now is chartering 2 airplanes. One airplane will fly from Punta Arenas in Chile in December of 2021 to see the eclipse, the total solar eclipse on December 10th, I think it is that year. No, December 4th, sorry. And you know, that's going to be an amazing thing because there are only a couple of planes. The weather prospects are horrible. There's going to be a lot of cruise ships in that Antarctic Sea area, but the weather prospects are horrible. There could be only a few hundred people that get to see that eclipse, and some of them
Sure.
might be on our plane.
sure.
And the other thing I'm working on is about this time next year, there's going to be an annular eclipse that is going to begin in south central Canada, not far from the border with Minnesota. Again, the weather prospects are horrible, but I'm trying to charter a plane that will take a couple of dozen people up to altitude to see an annular eclipse at sunrise. So that's what I do in my spare time.
Nice. Sounds like fun. Well, thanks very much. Anyone else have questions?
Come on, Mario, say something snarky. Go ahead.
Well, thank you, Kelly.
I'll ask you a question then. The magnetic pole is actually moving over toward Russia, and it's just past the true pole now.
Yeah.
So that means our side of the world is going to start getting less and less great auroras. It's going to move further north. Is that not true?
Yeah, there's actually, I took that slide out for this one, but I have such a slide. There are actually 3 poles. There is a rotational pole, there is a magnetic pole, and then there is a geomagnetic pole. And so the geomagnetic pole is the pole that is the center of the auroral oval, and I'll have to check, Mario, but I think that is the one that is not moving. It's the magnetic pole that is moving.
Sounds good. All right, Kelly, thank you very much. That was awesome.
Yeah.
That was fantastic. James, you want to roll? Where's James?
Sure.
I hear him.
Okay, let's see here. Here we go.
There you go.
Okay, look good?
Looks great.
Okay. I had the opportunity to go on a tour of Australian observatories this past October. This will mostly be pictures from the trip and a few stories. The tour started on October 1st, but I wanted to get there a little early so I'd have time to recover from jet lag. Sydney's 14 hours ahead of Boston, and with the international dateline, that meant leaving Boston on September 28th to arrive on September 30th. Getting there early gave me an extra day to explore Sydney on my own. As a side note, daylight savings time started in Australia on October 6th, so I got to lose an hour of sleep twice. The map here shows roughly the path we followed. Marnie Ogg, who won the IDA's International Dark Sky Defender Award in 2018, led the tour along with her husband, Fred Watson, Australia's astronomer at large. This is Sydney Observatory. It was built between 1857 and 1859 on Windmill Hill, where it's visible from much of Sydney Harbour. Knowing your position at sea required knowing the time, so the golden ball you can see on top of the tower is a time ball. Every day at 1 p.m., the ball dropped and a cannon fired so that ships could set their chronometers. The observatory's clock was set through measurements with a transit telescope, which was precisely aligned with the meridian and could only move in altitude. Its eyepiece has 5 hatch marks to aid in transit timing. The time ball is still dropped every day at 1 p.m. You can see here there are 2 domes. Now, the original design in 1854 did not include the time ball tower because the architects didn't know how they worked. As the plans were revised, the tower was added and its height increased. When the first government astronomer, Reverend William Scott, was appointed in 1856, he was unhappy at the prospect of having a portion of his sky blocked, so the second dome was added to get around this problem. The south dome, which is the closer one on the last slide, houses a 7¼ inch refractor made by Georg Merz and Sons in 1861. This is the same Georg Merz who, as part of Merz and Mahler, produced Harvard's 15-inch Great Refractor in 1847. The north dome has a Meade LX200 and a Lunt LS80T. I'm told we shouldn't worry about having the counterweight above the telescope in the picture on the left. It's not upside down, it's in Australia. The telescope on the right is the transit telescope that I mentioned. It's featured in the observatory's museum now. You can see the narrow windows that it looked through when it was in use. We had dinner that night at the Sydney Opera House. We started day 2 with a tour of the northern beaches that took us to Barrenjoey Head. The head is a tide island. It was part of the mainland that got cut off due to rising sea levels about 10,000 years ago. The subsequent buildup of the sand spit re-established the connection. The lighthouse here is built out of sandstone like almost every building in Sydney. An Australian soap opera called Home and Away films on these beaches. After we left Barrenjoey Head, we traveled inland to Parramatta. Dr. David Malin gave a talk along the way about his life, the chemical processes he used to extract faint data from film and plates, the creation of color images from monochromatic film, and the discovery of Malin 1, which was the largest spiral galaxy known to exist. Once we got to Parramatta, we visited the old government house. Governor Brisbane preferred to stay here rather than in Sydney because it was a better site for his observatory. The observatory operated from 1822 to 1829 and from 1831 to 1847 when it fell into disrepair and its instruments were moved to Sydney. The mount on the left is all that remains today. The obelisk on the right marks where the transit scope was mounted. That location was used as the initial meridian for a trigonometric survey of New South Wales in 1828. Day 3, we headed inland to visit Echo Point and the rainforest in Katoomba. The rock formation on the left is called the Three Sisters. I was a quarter mile away at Echo Point when taking this picture. If you look at the left side of the picture, you can see a bridge for tiny little humans. The rainforest is on the right. We were warned not to leave the path because it could take days to weeks to find us if we got lost. That may be an exaggeration for tourists, but I chose not to find out. To the lower left, you can see Pluto, the first stop along the world's largest solar system drive, which extends 190 kilometers out from Siding Spring Observatory. Fred Watson was instrumental in getting this set up. Work on it began before the IAU's 2006 decision, which is why Pluto was included. The bottom right picture is from Scenic World, which had the rainforest tour in the last slide. Scenic World has a skyway which is suspended 270 meters above the ground. It also has a railway with an average 52-degree slope and a 128% maximum gradient. We stayed overnight at the Mountain Heritage Hotel in Katoomba in the picture at the top. There were lights on all of the telephone poles that you can see, but once our eyes were adjusted to the dark, we could see the large and small Magellanic Clouds as naked eye objects. We knew that there was a drought going on in New South Wales, but Katoomba is where we first got an indication of how bad it was. Newspapers in the hotel lobby told us how many days or weeks it would be until various towns ran out of water. Sydney was expected to have enough water to last several months, but some towns near Katoomba would run out of water, even for firefighting, by the end of October. Day 4 brought us from Katoomba to Coonabarabran, and then from there the extra half hour up to Siding Spring. Coonabarabran calls itself the astronomy capital of Australia. It's on the signs into town and everything, and we passed a lot of homes with their own observatories. I was eager to see the iTelescope Observatory, since I've used their service. There was a terrible joke painted on the van, which the Siding Spring Observatory staff use when picking up guests. If you can't quite read it, it's been designated the Space Shuttle. Australia is no stranger to bushfires, as will come up again later in this talk. There was a bushfire in January of 2013, which swept through Siding Spring. All the observatories and instruments survived because they were prepared, but the one building that didn't was the residence for visiting astronomers. A new lodge was built and opened in June of 2017. We were the first group of international visitors to stay in the lodge. It was very comfortable, and every window had shutters which could close and completely block out any light coming from the room at night or going into the room during the day. The telescope you see at the top right is the UK Schmidt telescope with a 48-inch aperture. The blue box on its side allows instruments or 35-centimeter plates to be swapped. The picture at the bottom left was from an annual event in Coonabarabran called Science in the Pub. The evening started with a buffet of Chinese or barbecue. After dinner was over, a panel of experts got up on stage to talk about recent scientific developments and then took questions from the audience. At the end of the evening, we drove back to Siding Spring to bed down for the night. I brought my travel mount with me to Australia and didn't want to miss the opportunity for a little imaging. This is a stack of 16 10-second frames I took at ISO 25600 through a 10mm fisheye lens. The clouds at the bottom and left are just clouds, as are the clouds at the top right. But on the right in the middle, we've got the large and small Magellanic Clouds. Day 5 of our tour coincided with Starfest, an open house and astronomy festival at Siding Spring Observatory. The picture at the left is the 3.9-meter Anglo-Australian telescope. We were able to tour the AAT and see its control room as part of this event. Our tour leader, Marnie Ogg, spoke about light pollution. The picture at the top middle is from her talk. Kirsten Banks, who we met at Sydney Observatory, gave a talk about Aboriginal astronomy. The other two pictures are from my tour of the iTelescope facilities. They've got 10 publicly available scopes on site, plus a number of other instruments that they're hosting. I'm not sure whether the scope at the right is a PlaneWave CDK 500 or a CDK 700. The top picture shows a number of other observatories at Siding Spring. The Anglo-Australian telescope is the dome at the far back of the picture. The big rotating observatory towards the middle is the 2.3 meter ANU telescope for the Australian National University. The other two pictures are the control panels for the Anglo-Australian telescope. I'm going to go through this slide pretty quickly. After Starfest, we went to Pilliga for lunch at a pottery school and cafe. We went on a hike around the Pilliga Nature Reserve. The rock that you see at the top left is sandstone, like in Sydney, that was carved out by the wind. Then we visited an emu farm where there were a lot of flies. The levels in the Australian fire danger rating system are low, moderate, high, very high, severe, extreme, and catastrophic. The next day we made it down to Parks. We stopped off at the hotel first to check in and drop off our bags and get a little lunch. A dust storm passed us by, which is why the sky looks red in the top right picture. The metal structure in the foreground of the left picture is about 2 stories tall. It's a secondary assembly that can be swapped in at the top of the Parks Observatory dish. I'm told the picture at the bottom right should look familiar to anyone who's seen the movie, The Dish. Starting at the top left, Parks had a poster on the wall of the heart rates of Neil Armstrong and Buzz Aldrin as Armstrong stepped onto the moon. The original was at Honeysuckle Creek and was misplaced when that facility shut down. John Sarkisian, operations scientist at Parks in the picture at the right, is trying to track down the original so it can be sent to NASA. At the bottom left, they had a prototype phased array feed for the square kilometer array on display. It's planned to be built in South Africa and Australia starting in 2021. In the middle, we have a sample of the David Malin Award for Astrophotography. You may recall David told us about his career on the bus ride to Parramatta. On the right side, we have a portion of the control room for the Parks Observatory, along with John Sarkisian. There's a little bit to unpack in the bottom right picture. We'll start with the sign at the left. The Parks Observatory is a radio telescope, so mobile phones and Wi-Fi have to be shut off or put into airplane mode while on site. Photography and videography are encouraged. We were told that they have 2 of the top 3 deadliest snakes in the world in the area, so we should let them know if we saw a snake anywhere. They have a snake catcher on staff who will catch it and move it to a safer location. And last, drones are not allowed at parks for the same reason as cell phones. The radio signal would throw off their measurements. In fact, we were told that if you put an iPhone on the moon, it would be the brightest radio source in the sky by orders of magnitude. One thing I had not realized about Parks is that the dish's mount is not bolted to the building. The dish and its mount weigh over 1,000 tons, more than 2 Boeing 747s. They just sit on top of the building and let gravity do the rest. We had dinner that evening at Parks and did a little observing before we went back to the hotel. The picture at the right shows Professor Fred Watson, Australia's first astronomer at large, and David Sarkisian, operations scientist for Parks, trying to repair the daub they have just broken while our bus driver holds a light steady for them. We stopped in the Devonian Age of Fishes Museum in Canowindra on our way from Parkes to Canberra. The story goes that a construction crew was digging for a road in 1955 when they uncovered an unusual rock slab. They put it off to the side and kept working. A local beekeeper spotted it sometime later and thought it looked like fossils, so he alerted the Australian Museum. This led a team of paleontologists under Dr. Alex Ritchie to descend on the site in 1993. The funds ran out after 70 tons and 3,000 fossils had been extracted, so the rest were buried back underground and the road was paved above them. Once we got into Canberra, we had the evening to ourselves. I didn't know anything about the city, so I pulled up Google Maps. The first thing I saw was a TARDIS from the TV show Doctor Who. I have a niece who's a huge Doctor Who fan, so that's where I was going to go. And then I uttered the fateful words, "It's only 3.6 kilometers. I bet I could make that before dark. Why does Google think that should take an hour and a half to walk?" I put my camera in my backpack, filled a couple water bottles, and left. I figured that crossing the bridge would be the first kilometer. Getting partway around the circle would be the second. And making it to the end of Embassy Row would be the third. Okay, it took a little longer to get there than I thought. The sun had set, but surely I was almost there. That's when I discovered the entire last half kilometer was entirely uphill. Even though there were streets, because it was a designated park, there were no street lights, and there weren't any sidewalks anywhere. Why should I find this disconcerting just because Parks had told us about all the deadly snakes? But there was no backing out now. After only an hour and 45 minutes, I made it to the top. I found the TARDIS was down another long staircase, and then I took a rest at the panoramic overlook where I could see all of Canberra. I didn't have my tripod with me, but it was pretty clear, so I wanted to take a picture. There was a stone wall which was angled up a little, so I set up on that and pointed away from the city. This was the one place I was able to take pictures of Omega Centauri, which is circled in green right here. That would be the end of the story, but I still had to get back to the hotel. As I made my way back, I remembered that there was a park by the lake with a bunch of interesting sculptures and such in it. I took a slight detour to visit it, knowing that the path would take me back to the bridge. I was walking along a path in the park when I noticed some movement to my right. No more than 30 feet away were 5 kangaroo. What a great photo opportunity. I took out my camera, turned it on, took off the lens cap, and put up the flash. Then I had a thought. I'm in a foreign city, in a foreign country, on a continent where everything is trying to kill you. Nobody really knows where I am. I can't be seen from the road, and I don't know how to get help here. These are wild animals capable of mauling a person. Is startling them really the smartest thing for me to do? Put the flash down, put the lens cap back on, turned the camera off, put it back in my bag, and kept walking. Once I got back to the hotel, I figured out why the trip had taken me so long. I transposed the digits when looking at Google Maps. It wasn't 3.6 kilometers, it was 6.3 kilometers in each direction, almost 8 miles in total. Oops. Our first astronomy-related stop on day 8 was Honeysuckle Creek. The dish that relayed the first 8 minutes of the Apollo moon landing used to be here. Armstrong and Aldrin rearranged their schedule by 5 hours so that they could walk on the moon sooner, and Parks just couldn't point low enough. Honeysuckle Creek was further to the east, higher in elevation, and had a design which let them point lower to the horizon. They also had a slow scan converter, which let them flip the image from the moon so it was right side up. When Parkes did take over, they were violating all of their own safety regulations. The minimum elevation angle for the on-axis instruments with Parkes was 30 degrees, and the maximum safe wind speed was 35 kilometers per hour. The wind that day was gusting to 110 kilometers per hour. They had to use off-axis instruments to pick up the signal from the moon at all until it rose higher in the sky. Honeysuckle Creek was closed in December of 1981. Its last mission was in support of the Pioneer Venus orbiter. Our next stop was in Tidbinbilla at the Canberra Deep Space Communications Complex. The picture at the top left is a moon rock, which NASA gave them in appreciation of their assistance with the moon landings. It's now on display in their museum, along with many other space-related artifacts. The top right is the Honeysuckle Creek radio telescope, which handled the first 8 minutes of the moon landing. It was moved to Tidbinbilla from Honeysuckle Creek when they shut down, and it's still in use to this day. The bottom picture is the control room for the entire Deep Space Communications Complex. Each desk has 7 monitors plus 4 overhead. I don't think you can see it from this picture, but our guide around the complex looked like an Australian Conan O'Brien. Now I'll warn everyone, the next slide may be hard to look at. The last stop on our trip was the remains of the Mount Stromlo Observatory. The observatory was totally destroyed by a bushfire in 2003. The key finding, which saved Siding Springs 10 years later, was that embers had gotten in through the windows and caused papers and furniture to catch fire. Siding Spring took the protective step of installing ember gratings over the windows of their observatories. The last picture I want to tell you about is at the bottom left. This is Lake George, which we passed on the way from Canberra back to Sydney. Lake George is an endorheic lake, which means that water only flows into it. It measures 16 miles long by 6.2 miles wide. Now you may be wondering, if it's a lake, where's the water? That's what makes Lake George interesting. It's not always a lake. When it is, its average depth is about 1 meter, and it's almost as salty as the ocean. It can fill and empty again within as little as several hours. The other 2 pictures are from Logan Airport. In a trip which talked so much about the moon landings, seeing these when I got home felt like a nice bookend. Thank you for your attention, and there's one more quick note, which is, while Mario was talking, I got a note from John Sarkisian, the operations scientist at Parkes, who gave me a bit of extra information. He said the CSIRO Parkes telescope has an elevation horizon of about 30 degrees. The Apollo 11 moonwalk TV began when the moon was still about 8 minutes below the telescope's horizon at approximately 28.5 degrees elevation. Parkes was able to receive the TV signal with its off-axis feed, which gave it a view of 1.43 degrees below the telescope's horizon. 8 minutes later, when the moon had fully risen above the telescope's horizon, Parkes was able to track it again using the main on-focus feed. That's when NASA switched to the Parkes TV signal and stayed with it for the remainder of the 5-hour broadcast. Minutes before the TV was switched on, and when the dish was fully tipped over, waiting for the moon to rise, a violent squall hit the dish. Gusts of 110 kilometers per hour buffeted the dish. We normally stow the telescope when winds reach about 40 to 45 kilometers an hour. Fortunately, the wind slightly abated just as the TV switched on. The winds remained high throughout the TV broadcast, with the dish operating well outside its safe limits. In fact, toward the end of the broadcast, it hailed at Parkes with No degradation of signal strength or picture quality. And that's the end of the note from John and the end of the talk. So thank you very much. And are there any questions?
Thanks, James. Yeah, anybody have any questions? My slide is about observing in the daytime, and I'm going to do it. I'm going to give you a little bit of a flavor for what I was going to talk about. And I'm going to give you a homework assignment to go out and try and find Venus in the daytime. It's important to remember that the sky is extremely bright, and although Venus is going to reach its greatest brilliancy tomorrow at minus 4.7 magnitude, that's really bright. You can see it with your naked eye in the daytime if you know where to look for it. But if you want to look at it through a telescope, the very best method I have found of all the telescopes I own is to use my good old Dobsonian mounted 10-inch reflector. It's got an 80 millimeter finder scope. And it's just a simple up and down and all around sort of telescope. If you've ever worked with the Dobson, you know how easy they are to use. It's important to note a couple of things. I found most success came from having a collimated telescope, having the finder scope lined up with the main telescope, reasonably so. It doesn't have to be perfect. You just have to know where it is lined up. Now you can line up your finder scope in the daytime by just aiming the telescope at some very distant object. The further away, the better. And then acquiring it in the finder scope, make your adjustments, and then everything should be pretty good. It's important when you're looking for things in the daytime sky that your telescope be pre-focused. And if I have made marks on telescope draw tubes. I've got a GSO focuser that's got graduations that I have a pretty good idea where my focus lies. Or you can, while you're lining up your finder scope on something really, really far away, you can use that as a rough focus for your telescope. The problem with having an out of focus telescope is that just from your experience of at nighttime observing, when you defocus a star, you know the disk, it forms a faint disk of light. Now imagine the sky around that faint disk of light isn't dark at night, like it is at night, that it's bright blue from the daytime sky. And in a moment, your object just melts into the background and you're never going to find it. So a pre-focused telescope is really important. Now, there are equatorial mounts. There are go-to mounts. And I know they can be used to find objects. But again, just so I can give you a flavor for this talk, the method that I have had the most success with is this one here. I use my app, my astronomy app. I use Sky Safari Pro. You could use Stellarium. There are a whole bunch of them out there. What I do with that app is I ask it for the particular time I'm going to look, please tell me the altitude and azimuth of Venus. How high is it in the sky and what direction should I point in? And that's how I start. And so once my telescope is ready to go, I literally use my iPhone. It's got a compass app. On this particular day, Venus was allegedly at 149 degrees in azimuth and 63 degrees above the horizon. I find the tilt meter in the iPhone to be more accurate than the compass. I think the compass is just too easily affected by things around it, like automobiles or metal tubes on telescopes, maybe. But I've always noticed that the compass is the least accurate of the two measurements. So what do? I look up the altitude and the azimuth. I put my phone on the telescope and turn the azimuth mount till it's roughly pointed in the right direction. I switch to the tilt meter and I move the telescope up until I'm at the right altitude. Now, these are iPhone pictures, but I know they sell apps for Android phones where you could do the exact same thing. And the nice thing about having a finder scope lined up with the main telescope is that I can find Venus in my finder scope easily. I could see Venus in my finder scope 2 days before it reached inferior conjunction. It was about 3 degrees away from the sun at the time, but I could see it in the finder scope. And so that makes it a nice, easy way to, this is a rough pointing system. So get yourself in the ballpark, use your finder scope to sweep in azimuth, and you'll see it. you'll pick it right up, and then you can center it and you can look. And what is it going to look like in your, when you do this right? Well, there it is. It took me literally about 20 seconds to find Venus and to sit down and just have a good old time observing it. And you can do the exact same thing. If you have an equatorial mount that's not polar aligned, you can move it so that it is acting like an alt-azimuth mount. If you've got a go-to telescope, I have a Meade ETX 125. And what I like the least about that telescope is it forces me to be a slave to its computer. You have to wait for it to go through its alignment. You have to trust that it's going to point in the right direction. There's barely a finder scope on the telescope, and it makes finding things in the daytime particularly challenging, even Venus. So if your telescope, any of those telescopes, equatorial mount, even your go-to telescope, turn off the go-to part, use it as an azimuth system. And you can do exactly the same thing I've done and take advantage of the fact that Venus is very far away from the sun, perfectly safe to look in that part of the sky. And you'll get to actually observe it in the daytime sky. With planets, I've had good success with Venus and Mercury. I've looked at Jupiter and Mars in the daytime sky. But I'll talk more about that when I give the full talk. I just wanted to share this little kernel of knowledge, of information, a few tips on how to make the most of your observing experience. I love having the telescope out in the daytime, and I love to look at Venus. And so you can too. And that's all I'm going to share with you right now because it's getting a little bit late. And I'm going to ask if anybody has any questions about this technique. Anybody have questions? I think I can see most of you. Just speak up if you do. No?
What are
It's
your
easy.
best,
Go ahead.
sort of best safeguards against the sun? Just good tips and tricks for safety.
Well, not to go there. That's Corey, right?
Yep. Yeah.
So when I was looking at, when I was watching Venus approach inferior conjunction back in May, I knew I was going to get closer and closer and closer to the sun. And I wanted to actually see how close I could actually get. It was a shade above 3 degrees away from the center of the sun. So maybe 2 3/4 degrees away from the limb of the sun. That's treacherous territory. That's not for the faint of heart. As a matter of fact, I told Roger Ivester this story. I was, on that day, I was using my finder scope to look for Venus in the finder, just to see if I could see it, and I could. But then I noticed something really strange. I noticed these beautiful black clouds in the sky. Beautiful. They were moving and it just looked wonderful. And I thought to myself, wait a minute, there are no black clouds like that in the sky. What I was looking at was smoke in the finder scope. I was melting the finder scope on the inside. I was so close to the sun. And so you have to be careful. I used a long sun shield in order to cast a shadow across. I was using one of my refractors, the 3-inch refractor I have. And I used a long, like a 3-foot long sun shield after I calculated how tall does the shield have to be so that the shadow covers the objective. I was really trying to minimize glare. And every day it got longer and longer and longer until it became impractical. But observing near the sun is really dangerous, and I only recommend it to the most experienced observers. You really have to be careful, and you cannot be sweeping near the sun. That is just a recipe for absolute disaster. You have to really know where you are with your telescope when you're looking close at the sun. Because remember, these telescopes are unfiltered. Looking at Venus, there's no filter on that telescope. And so you have to be extremely careful, and I don't recommend it unless you're really experienced. But Venus is really far away from the sun right now. Venus is probably 40 degrees away from the sun. So that's perfectly safe and easy to do when Venus is as bright as it's going to be this week and next and the week after and the week after and the week after. You can get out there and see it. You can watch Venus from inferior conjunction all the way back to superior conjunction. Another fun, challenging time is catch it at superior conjunction, where the disk is small because Venus is far away from us, but it's fully illuminated. You never see it that way. And again, you just have to be careful because you're playing pretty close to the sun at that point. But that's all I wanted to talk about tonight. My talk will just take us into too late of a time. So I'll save the rest of it for later on. I'll tell you up front, the setting circles and the go-to telescope were not successful Not at all successful enough for me when I was looking for stuff in the daytime. I've had much more luck just doing the alt azimuth, and I know you guys can too. So it's something to play with. You just got to be patient. You got to practice. And if there was one tip I could give you at all about it, make sure that telescope is pre-focused. Kelly, I see your hand up. Do you have a question, a comment? Kelly? Nope, never mind. Bruce, go ahead.
So have you observed Venus naked eye in the day? And
Oh, sure.
What's that experience like?
Well, if you know where to look for it, it's easy to pick it out of the blue sky. But that's the hard part, actually. I sometimes I amaze even myself when I'll be like, when I finally see it, it's like, how come I could not see that for the last 5 minutes? And you really have to sort of zero in on it. You have to relax your eyes. They need to be focused at infinity. If the moon happens to be near Venus, that's a perfect opportunity, because when the moon is there, if you know where Venus is relative to the moon, then it makes it easy to see. And I've shown lots of people, dozens and dozens of people over the years, Venus in the daytime. And a lot of even astronomers are surprised that you can see it. But a -5th magnitude, I'll another tease, one of my first slides in my talk shows I plotted the Bortle scale against limiting magnitude, naked eye limiting magnitude. And in the daytime sky, if you set the naked eye limiting magnitude at -4, that's a Bortle 24 sky. So it's really light polluted. It's really hard to find things in the daytime because the sky is so bright. And Venus, even at -4.7 magnitude, has a way of sort of hiding itself until you actually spot it. And then once you see it, you're almost home free at that point. If you can line it up near some nearby object like the peak of a roof or a tree branch, it might make it a little bit easier to find it. But the alt azimuth method that I've used it for decades, and it works almost flawlessly. Like I said, the real weak link in the system is the inaccuracies of the compass. But so you learn. You set the altitude, you sweep it a little bit east to west in azimuth, and if you're using your finder scope, which mine has a 3.5 degree field, it's pretty easy to find it actually. And so I think everybody should give it a shot. It's just another opportunity to get outside and do some observing, you know?
Yeah, my experience with seeing Venus naked eye in the daytime is sort of like an averted vision apparition. It will suddenly appear, and once it does, then you've got it.
Yep.
But like you were saying, you can be looking right at it until the mind takes over and sees it. It's not there. It's a really strange experience.
Sometimes I see a lot of noise. I'll call it noise in my eyes. I have to kind of close my eyes and blink a few times and look away from the sky and then try it again. But it can be done. It's just another tool in your toolbox of ways to observe. I don't know how many folks here tonight have actually taken the time to go out and look for Venus in the daytime. I think it's fun. You can always follow it into the light. If you were to get up to look at Comet Neowise, Venus is really bright in the east. Put in your telescope and track it all day long until it sets. You'll be able to see it just fine that way. But if you drag a telescope out of the garage and plunk it down in your driveway, how are you going to find Venus? The easiest way, the most successful way I've used is alt azimuth. So that's all. That's all. Anybody else have questions?
I do.
Yes, sir.
Well, I did get a telescope. I don't know if it's the same quality. My grandmother gave it to me for like a birthday gift. So if I was gonna find the time to do the assignment to like see Venus, first of all, what time does it usually appear during the day if I'm going to look at the clock? And and second of all, is there, if it turns out that the telescope doesn't work, will I also be able to see it with my eyes like next to the sun?
Well, Well, I just looked it up on my Sky Safari app. Venus right now is located 39 degrees away from the sun. So if you held your hands up like this in the sky, you can see them like that, thumb to thumb, fingertip to fingertip. From one fingertip to my thumb here is about 20 degrees at arm's length. So 2 of those is about 40 degrees. And if I hide the sun with one little pinky finger here and make an arc like this, I should be able to get a rough idea where Venus is in the sky relative to the sun. Its altitude and its azimuth, of course, changes as the day goes on. And so if you were to get out in the early morning, like pre-sunrise, Venus is over in the east, pretty low in the east. But as it rises up and crosses the sky and sets later in the afternoon, its altitude and azimuth change. And that's why I use Sky Safari Pro to give me altitude and azimuth estimates that I can then use to move my telescope to the right position. It doesn't take a lot of, you can see it with your naked eye. So it doesn't take a lot of telescope power, aperture, or magnification. Keep the magnification low to start. And if you follow your app's instructions, if you will, the altitude and the azimuth at that particular moment in the day, and point your telescope in that direction, you'll be far away from the sun, so you don't have to worry about any of that. And if you be patient, sweep around, up and down, left and right, and you might well pick it up. I think, again, Phil, the most important tip is to pre-focus that telescope. If it's not pre-focused,
Okay, so
it's going to be hard.
Venus is basically like 10 fingers like away from the sun is what it is, and it's going to be looking like a half a disk, like you would think it's a moon in a way, right?
That's right. As a matter of fact, that picture you can see on my screen right now was just taken 2 days ago.
Yeah, Philip, just to jump in here, you need to get up before dawn. Not a lot before dawn, but if you get up before the sun rises and just look toward the east, you'll see Venus. It's very, very obvious. And that would be the time that you want to point your telescope at it. That'll be the easiest time. And then just keep following it. I don't know if your telescope tracks or if you just have to move it manually, but either way, just keep following it. And you should be able to keep following it even after the sun rises.
Yeah, sunrise tomorrow is about 5:20 tomorrow morning. So if you went out at say 4:30 and looked to the east, you could easily see Venus. It's super bright. After the moon, it's the next brightest object in the sky right now. And so it's an easy object to find. And Kelly's right. If you put your telescope on it early in the morning and watch it and track it as it moves, as we rotate, you'll be able to see it well into the daylight, and you can follow it as long as you care to, you know.
So
Third brightest.
Well, after the moon, it's next brightest after the moon.
But the sun.
Well, the sun's first. The moon is second, and
Right.
we found the sun on the first day. That's easy. And the moon is actually in the morning sky now. So if there was ever something you wanted to pre-focus your telescope on, point it at the moon, make sure it's focused, and then go look for Venus.